Today we're finishing up, we're dealing with section 4.5, which is the end of chapter 4, and we're talking about rational functions. With a rational function, anytime you hear the word rational, you're talking about some sort of fraction. And with a rational function, you are talking about a function that is made up of a fraction of two polynomials. We're going to call the numerator p of x and the denominator q of x. So p and q are polynomial functions, and once again the limitation we have is the denominator q of x cannot be 0. So let's take a look at 1 over x. Think about the graph of that function. If we look at it, and we can make a t-chart just in our mind here. As we make a t-chart, you think about when x is 1, we're going to get a value of 1. When x is 2, we're going to get a value of 1/2. When x is 3, we're going to get a value of 1/3. When x is 1/2, we'll get a value of 2. When x is 1/3, we'll get a value of 1. So what happens is we're going to get this sort of a shape on the right-hand side of our graph. As x gets bigger, the function gets closer to 0. As x gets closer to 0, the function gets bigger. When you put in a negative value, let's say -1, you're going to get -1. If you put in -2, you're going to get -1/2. -3 will give you -1/3, and so on. When you put in -1/2, you get -2. And so we see what this graph looks like on the left-hand side is like that. And so that is what the graph of 1 over x looks like. As we look at this, f of x approaches infinity as x approaches 0 from the positive side, and f of x approaches negative infinity as x approaches 0 from the negative side. When we think about f of x, the end behavior, f of x approaches 0 as x approaches infinity, and f of x approaches f of x also approaches 0 as x approaches negative infinity. The line x equals a is a vertical asymptote of the function y equals f of x if y approaches infinity or y approaches negative infinity as x approaches a from either the positive or the negative side. The line y equals b is a horizontal asymptote if of the function if y approaches b as x approaches infinity or negative infinity. This horizontal asymptote is dealing with our end behavior. So what we want to do here with this graph is we want to make a quick t-chart to get an idea of what this looks like. So let's make a quick t-chart over here. If we put in, let's say, a 5 and a 4 and a 2 and a 1 and a 0. So looking at 5, you're going to have 2 over 5 minus 3, that's going to give you 1. If you put in a 4, it's 2 over 4 minus 3, that's going to be 2. If we look at 2, that's going to be 2 over 2 minus 3, that's negative 2. If we look at 1, that's 2 over 1 minus 3, that's negative 1. And 2 over 0 minus 3 would be negative 2/3. So now if we graph these points, what happens is we're going to get 5, 1, which would be right here. We're going to get 4, 2, which would be here. We're going to get 2, -2, which is here. 1, -1. 0, -2/3. Now, notice what happens when x is 3. When x is 3, we get 2 divided by 0, that's undefined. When we have that situation, that's where we get this vertical asymptote. And so that happens when x equals 3. And now, if you look at this graph and you put in some more points, we find out we're going to get the same sort of a shape as we had before with 1 over x. The difference is the vertical asymptote has been moved over to the left, or sorry, to the right 3 units. And that should make sense because right here, if you think about what's happening to the x, you're subtracting 3, so that moves the graph to the right 3 units. And you can see the graph there, scale's changed a little bit, but vertical asymptote at 3, and then the curves going as we had them drawn. For the next one, again, if we want to make a t-chart, t-chart might not be the best way to do this, but a couple things we can find is, first of all, we can find vertical asymptotes by figuring out when the denominator equals 0. So let's go ahead and do that. If we factor this denominator, it factors as x and x. The signs are the same, both negative, and factors of 1 that will add up to be -2. So we get that. On the top, we'd have to find factors of 2 times 5 is 10, and there's no factors of 10 that will have the same sign and add up to be -4. So that one doesn't factor. But what this does tell us is when x equals 1, our function is undefined. So let's put in a couple of values on either side of 1. An easy one to use is 0. And let's go -1, and then let's go with 2 and 3, just to get an idea of what this looks like. So if we put in 0, we're going to get 5. And if we put in 1, or I'm sorry, -1, notice we're going to get 2 plus 4 plus 5, so that would be 11 on the top. And on the bottom, we're going to have 4. You've got 1 plus 2 plus 1 is going to be 4. So that is 2.75. So quickly to graph those, we've got 0, 5, and -1, 2.75, which is going to be about there. If we put in a 2, that would be 8 minus 8 plus 5. That's going to be 5 on the top. On the bottom, it's going to be 1. So that's just 5. You're going to have 4 minus 4 plus 1. And then if we put in a 3, we're going to have 18 minus 12 is 6 plus 5 is 11. And on the bottom, we're going to have 9 minus 6 plus 1 is 4. So notice here, we're going to have this 5 right here. And once again, at this point, we're going to have this 11/4. These equations are going to always have this sort of a curved shape. And notice what happens this time. Because the denominator is squared, both of these curves are actually on the top of the graph, rather than one on the top and one on the bottom. So again, you can see that. Again, the scale is a little bit different from what our picture was, but that's a little bit nicer picture of that. You see your vertical asymptote. There's also this green line here, which we didn't talk about, and that is actually the horizontal asymptote, which is at 2. So my picture actually wasn't quite to scale. We should have had a horizontal asymptote of 2, and we're going to talk very shortly about how we get that horizontal asymptote. So looking at this rational function, notice the top is just our normal polynomial function equation. The bottom, since we have to make it different than the top, it's just another polynomial function equation. So to find the vertical asymptotes of this function r, these are the lines x equals a, where a is a 0 of the denominator. In other words, it's any time the denominator equals 0, you will get a vertical asymptote. The second part is for horizontal asymptotes. If n, the degree on the top, is less than m, the degree on the bottom, then we have a vertical asymptote, and it is y equals 0. So that's one case. But we're always comparing n and m. The second case is if n and m are equal, then r has a horizontal asymptote, and it's just made up of the fraction from these leading coefficients, a sub n over b sub m. And finally, if n is greater than m, there is no horizontal asymptote, so you don't have to worry about it. So the three cases for horizontal asymptotes: if n is less than m, we get y equals 0. If n equals m, we get this fraction made up of the leading coefficients. And if n is greater than m, there is no horizontal asymptote. So now we want to find the asymptotes of this function. To do that, we have to factor it. So looking at the numerator, to factor that, we're going to take 3 times negative 1, and that gives us negative 3. We want to find factors of negative 3 that add up to be negative 2, and so that's going to be a negative 3 and a positive 1. Then we're going to rewrite this thing, 3x squared minus 3x plus 1x minus 1, and then we factor by grouping. So we can take out a 3x from the first group, and we have x minus 1 left over. We can only take out a 1 from this one. We have x minus 1, so our factors are, for the top, 3x plus 1 times x minus 1. On the bottom, actually I guess we didn't even need to factor the top, but on the bottom we have 2 times negative 2, which gives us negative 4. We want factors of negative 4 that add up to be 3, so that's going to be 4 and negative 1. So we do the same thing. 2x squared minus 1x plus 4x minus 2. We group them. So we have x we can take out of the first one, and we have 2x minus 1 left over. We take out a 2 out of the second one. We have 2x minus 1 left here. And so our factors for this are x plus 2 and 2x minus 1. So first of all, for the vertical asymptotes, that happens whenever this denominator equals 0. So that'll be when x plus 2 equals 0, or when 2x minus 1 equals 0. This one gives us x equals negative 1. That's one of our vertical asymptotes. This one takes a little bit more work, but we add 1 and divide by 2, so we get x equals 1/2. That's another vertical asymptote. For the horizontal asymptotes, that's much easier. Horizontal asymptotes, we simply look at the degrees, which are both 2, and since they are the same, that's that second case, and our horizontal asymptote is the line y equals 3 over 2, and that 3 over 2 comes from our leading coefficients. So that's all we have to look at for the horizontal asymptote. Vertical asymptote takes some work. Horizontal asymptotes are pretty easy. And you can see them listed there. Now when we're graphing rational functions, we're going to take a methodical approach to this. The first thing we want to do is factor the numerator and the denominator, just like you saw me do in that last example. We want to find the x-intercepts and the y-intercept, if there are some. We want to find the vertical asymptotes, if there are any. We want to find the horizontal asymptotes, if there are any. Then we want to make a little t-chart to put some other points on the graph, and then we want to sketch the graph. So that's the 6 steps we're going to go through pretty much each time we do one of these problems. So looking at this first one, our first step is factor. So let's go ahead and try and factor this. The bottom we'll factor pretty easily. X plus 2 times x minus 1. On the top, going through that process again, 2 times negative 4 is negative 8. The factors that will work there are a positive 8 and a negative 1. And so, let's do the work over here. We have 2x squared minus 1x plus 8x minus 4. And we factor by grouping then. We can take out an x from the first one. We have 2x minus 1 left. We can take out a 4 from the second one. We have 2x minus 1 left there. So x plus 4 times 2x minus 1. So that's the factoring. Next, we want to identify the intercepts. Well, to find the x-intercepts, we take the numerator and set it equal to 0. So that's going to give us x equals -4 and x equals 1/2 when we solve that. So let's go ahead and put that on our graph. X equals -4 right here, and x equals +1/2, which would be approximately right there. Then we want to find the y-intercept, and to get the y-intercept, you put in x equals 0, so that boils down to just being this divided by this, because everything else turns to 0. And so the y-intercept is going to be 2 in this case, so let's go ahead and put that point on there on the y-intercept. Then we want to look at our asymptotes. Horizontal asymptote, notice the degrees are the same, so we look at the leading coefficients, and we get 2 over 1. So our horizontal asymptote is going to be this line, y equals 2. Now remember what that means. That means as you go to the left and the right, the graph will get close to that horizontal line. The vertical asymptotes come from here. We're going to get x equals -2, and x equals +1. So to put the vertical asymptotes on there, -2 will give us 1, and +1 will give us another one. Remember what happens around the vertical asymptotes? The graph approaches infinity or negative infinity around those vertical asymptotes. The last thing we want to do here before we draw our curve is make a little t-chart. And what we're going to do is just pick some points on either side of these asymptotes. So let's pick maybe -3. Notice we've already got the -4 value there. We've already got 2 values in between those 2 asymptotes, and we need a couple values over here, so let's pick 2 and 3. And it doesn't matter what we plug this into, but let's just say the top one, or the factored form, we're going to have 1 times -7 over -1 times -4. So that gives us -7/4. Okay? Then if we plug in a 2, you're going to have 6 on the top. 4 minus 1 is 3. And on the bottom, you're going to have 4 times 1. So 18 over 4 is 9/2. And if we plug in a 3, you'll have 7 times 5 over 5 times 2. So notice the 5's cancel out, and we get 7/2. So let's go ahead and graph these points, and then we're going to see what happens. So -3, -7/4, that's -1 3/4. So -3, -1 3/4 is about there. Now remember what happens. As we go to the left, this curve will go through these points and get really close to that horizontal line. As we go towards this vertical asymptote, the 2 options are either up or down. And since this is curving down like this, we know it's going to go down, and it can't go past this x-axis right here because there are no zeros there. The only 2 zeros happen right here and right here. There's no zeros in this space right here. So we know it has to go down. In the middle here, we know it's going to go through these 2 points, and as it gets close to this vertical asymptote, it's going to go up. As it gets close to this vertical asymptote, it's going to have to go down. And then these last 2 points, 2, 4.5, and 3, 7, which is 3.5, 7/2, which is 3.5. So again, we're getting the idea it's got to go through here. As we go to the right, it's going to get close to this horizontal line. as we go close to this vertical asymptote, it's either got to go up or down, and this one has to go up. So after all of that, we're going to get this picture, and here's a little nicer view of it. Horizontal asymptote in green, vertical asymptotes in red, and the graph actually in blue. So let's look at another one. We're going to go through the same process. The bottom can factor, the top cannot. The bottom is the difference of squares, so it's going to be x minus 1 times x plus 1. So that's the first part. Then we find the intercepts. On the top, we're going to get, for a y-intercept, or I'm sorry, an x-intercept, we're going to get when x equals 2, we have one. And then when we look at putting in x equals 0, we're also going to get 2 there. So when x equals 2 and also when y equals 2. So we get 1 there and 1 there. So we found the intercepts. We want to find the asymptotes. Vertical asymptotes happen when x equals 1, when x equals negative 1. The horizontal asymptote happens, notice the degree on top is 1, and it's less than the degree on the bottom. And when that happens, our asymptote is automatically y equals 0. So here is the horizontal asymptote at y equals 0. The two vertical asymptotes happen when x is 1 and when x is negative 1. Then we just want to put a few points in between. And so notice we've got 1 point in the middle, 1 point on the right. We need a couple points on the left, so let's put in, what are some points on the left? Negative 2 and negative 3. We need one other point probably in the middle. Let's put in, let's say 1/2. And then one more point on the right, and let's put in a 3. So again, let's put it into the factored form. Negative 2, we put that in, we get negative 4 over, let's do the non-factored form. Negative 4 over 3, so negative 4/3. When we put in a negative 3, we're going to get negative 5 over 8. When we put in 1/2, we get 1.5 over 1/4 minus 1, 0.75. And that's negative, so that makes it negative 2. When we look at, oh, that's not right. This should be negative 5, negative 1.5 over negative 0.75, which is a positive 2. There we go. When we put in the 3, we get 1 over 8. So let's look at our points here and see what we can find out. So negative 2, negative 1 1/3 would be about right here. Negative 3 and negative 5/8 would be about right here. So that would make sense. As we go to the left, we're getting close to our horizontal asymptote. As we go to the right, it shoots down. With this one in the middle, we've got a 2 here at 1/2. I think I'm going to put in another point there. I'm not exactly sure what's going on yet with that. And then here we have 3 and 1/8. Okay. Now something kind of unique happens here. We know it goes through these 2 points, and we know it gets close to this horizontal asymptote, so that's what's going to happen there. But it goes through here, and it goes down. And so what happens, actually, with that information, I know what happens here. This is going to come down and then go back up. And the curve might not be exactly right, but again, we're looking for the main characteristics when we graph these. So you can see our graph is looking pretty close to what the actual picture looks like. Another one of these, again, we factor. The top can factor to be x minus 4 times x plus 1 when we factor that. The bottom, we can factor out a 2x, and we have x plus 2 left over. So that's the factoring. We find our intercepts. The x-intercepts are going to be at 4 and at -1. If you set that numerator equal to 0. The y-intercept, again, you're just going to look at the constant. Notice there is no y-intercept because you'll get -4 over 0. So it's undefined there. So there's no y-intercept. Then we find the vertical asymptotes. The vertical asymptotes happen when this is 0, the denominator. So that's going to be at x equals 0 and at x equals -2. So let's go ahead and graph that. We already talked about that there would be one here at 0. And there will be another one at -2. For the horizontal asymptote, the degrees are the same. So we take the leading coefficients, which are 1 and 2. So y equals 1/2 will be our horizontal asymptote. Once we have that information, we want to make our little t-chart. So we need a couple points to the left. Let's go with -3 and -4. And then we need maybe one more point in the middle. Let's go with -1/2. And then we need one more point to the left. Let's just go with what's convenient, 1. So then plugging it into, I'm going to go with the factored form. We're going to have -7 times -2 over -6 times -1. So that gives you 14 over 6, which is 7/3. If you put in a -4, you get -8 times -3 over -8 times -2. Those will cancel, and you get 3/2. If you put in a 1/2, we're going to have -3.5 and 1.5 multiplied together, and on the bottom we're going to have -1 and 1.5. So these will cancel. So you get positive 3.5. And if we put in a 1, you get -3 times 2 and 2 times 3, and notice that gives us a -1. So when we graph these points, that's -2 1/3, which will be about right here. I'm sorry, positive 2 1/3. Let's erase that. Which should be up here. And then positive 3/2, which is 1.5. That'll be right there, approximately. So again, that makes sense. It's going to go through here and get close to that horizontal asymptote. It's going to go up next to the vertical asymptote. What's going on here? Oh, wrong color. There we go. So it goes up there. Then we have -1/2, 3.5, which is going to be up here. So we can see what's happening. It's up here, and it's going down there. And then our other point, -1 would be about right here. So this one, again, is coming through these points, getting close to that horizontal line. As it gets close to the asymptote, it's got to go either up or down, and so this one's going to have to go down. Now, a slant asymptote is related to a horizontal asymptote, except it's going to be a diagonal line. And this is a diagonal line that the function approaches as x approaches infinity or -infinity. And again, we're talking about end behavior. A slant asymptote occurs when the degree of the numerator is 1 more than the degree of the denominator. That's the only time it occurs, when the degree on the top is 1 more than the degree on the bottom. And we calculate a slant asymptote simply by dividing the numerator by the denominator and then ignoring the remainder. The remainder ends up being the difference, or the area between the actual line and the curve that we're graphing. So as we move on to example 8, we see that we're going to graph this, and if we look at the degrees, and this isn't always what you check, but we can see that since we're talking about it, this is going to have a slant asymptote because the degree on the top is 2 and the degree on the bottom is 1. And so the top is 1 larger than the bottom. But the process we go through is exactly the same as what we've done before. So the first thing we're going to do is factor, if we can. And so on the bottom we have x minus 3, that doesn't factor. On the top we have x minus 5 times x plus 1. Different signs, and they have to add up to be negative 4. So after we've factored, we want to find our intercepts. So to find our x-intercepts, from here we get x equals 5, and here we get x equals negative 1. The y-intercept, remember, is just going to be when you put in an x value of 0, and that ends up being negative 5 over negative 3, which is positive 5/3. So let's go ahead and graph those. We've got 5 on the x-axis, we've got negative 1 on the x-axis, and then we've got 5/3 on the y-axis, which is 1 2/3, be approximately right there. So the next thing we want to do is find the vertical asymptote, and we can see from right here the vertical asymptote will be x equals 3. So let's go ahead and draw that. So you get that one. And then the thing that's different this time, horizontal asymptote, the top is bigger than the bottom. There is not a horizontal asymptote, but it is larger by exactly 1. And so what we have is a slant asymptote. And so as we look at this, we want to divide the top by the bottom. So let's go ahead and use synthetic division. There will be a 3 in my little box, and the numbers are 1, negative 4, and negative 5. So when we do that, the 1 comes down. 1 times 3 is 3. You get a negative 1. Negative 1 times 3 is negative 3. You get a negative 8. Now remember, this is your remainder. You're going to ignore that. So what's left here is 1x minus 1, and that is a y equals x minus 1. That's in slope-intercept form. So when we graph that, we start at negative 1, and our slope is 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, and so on. And so we find out, as well as I can draw this, that our slant asymptote is going to look like that. Okay? Now notice we already have 2 points to the left of the vertical asymptote, but we only have 1 point to the right of it. So when we do our t-chart, we really only need 1 more point. And let's go ahead and put in something as small as we can. Let's put in a 4. So when we put in a 4 here into the factored one, we've got 4 minus 5 is negative 1 times 4 plus 1 is 5. And on the bottom, 4 minus 3 is 1. So negative 5. So when we graph that, 4, negative 5, it's going to be right down here. Now remember what's going to happen. On the left here, the curve has to go through these 2 points, and then as it goes this way, it has to get closer and closer to the slant asymptote. As you get closer to the vertical asymptote, remember it has to shoot up. That's probably a little drastic of a curve. It probably curves a little bit more gradually than that. On the right-hand side, the same thing's going to happen. The curve comes through the points, and it has to go down there next to the vertical asymptote. As you go to the right, it's going closer and closer and closer to the slant asymptote. So that's what the slant asymptote does. It takes the place of the horizontal asymptote. In other words, it's going to get, the function gets closer and closer to that diagonal line rather than to the horizontal line it used to get close to before. So again, you can see those things, and this one actually came out pretty close to our graph, but the curves are a little more gradual than mine, but that is a little bit nicer picture of what this particular function looks like with the slant asymptote in green there. One more of these as we look at this, x cubed minus 2x squared plus 3. I don't know that we can factor, I don't think we can factor the top of this, and the bottom does not factor. So we're not going to worry about factoring. Let's go straight to the vertical asymptote. Notice that's going to be x equals 2, so we'll go ahead and graph that. And as far as a horizontal asymptote, the degree on top is 3. The degree on the bottom is 1, so there will not be a horizontal asymptote. But notice also there won't be a slant asymptote because the degree on the top is 2 more than the degree on the bottom. And a slant asymptote only happens when the degree on the top is 1 more than the degree on the bottom. So this is actually going to shoot off either up or down pretty quickly here as we look at this. Let's go ahead and find our intercepts. I guess we didn't find our intercepts. X cubed minus 2x squared plus 3. This one's going to take some work as far as the things that we've done before. So if we think about it, the possibilities are plus or minus 1, plus or minus 3, and that's it. So let's just check. We're checking the top here. I actually did these out of order. Sorry, I found the vertical asymptotes first, but we need to find the intercepts. So if we check this, we're going to have 1, negative 2, 0, 3. Let's go ahead and check negative 1. So that's a negative 1, and that'll be a 3. Negative 3, that'll be a 3. And a negative 3, and that one is going to work. So negative 1 is a factor. And then, as I look at that, it doesn't look like that's going to factor anymore. So let's use quadratic formula quickly. So x equals, it'll be positive 3 plus or minus square root of negative 3 squared minus 4 times a times c. And we can actually stop right there because notice right in here, you're going to have 9 minus 12, and that's imaginary. Imaginary zeros don't show up on a graph, so we can ignore, there will only be 1 0 there. We can ignore those imaginary ones. So the 0 that we're going to get here is negative 1. So right here, we're going to have a 0. Then also the y-intercept. Remember, that's when we put in x's that are 0, and so that's going to give us those two. That's going to be negative 1.5 for the y-intercept, which will be about right here. So now that we know that, we don't have any slant asymptotes or anything, we're going to have to just put in some points and see what happens. So as we look at this, let's do one more point to the left. Let's do negative 2. And then let's do some points to the right. We don't have any information over here, so let's do 3, 4, and 5 just to get an idea of what's going on there. So if we plug in a negative 2, negative 2 cubed is negative 8. That would be minus 8 again, and then plus 3 over negative 2 minus 2 is negative 4. So that gives us negative 16, negative 13 over negative 4. So 13 over 4. That should be a 13. Hopefully you can see that. 13 over 4. 3 cubed is 27 minus 18 plus 3 over 3 minus 2 is 1. So 27 minus 18 is 9, plus 3 is, that gives us 12. And we put in a 4. It's going to get big pretty fast. We've got 64 minus 32 plus 3 over 2. So that's 32, 35. That should be a 3. That looks like a 1. So 35 over 2 is 17.5. And it's just going to get bigger from that point. So let's see what's going on here. Let's go ahead and graph this and see what we can see. 13/4 is 3 1/4, and that is positive. So negative 2 and 3 1/4 is going to be there. So this side is working out pretty nicely.
We can see it's coming up, and it's actually just going to shoot off that direction. What has to happen here, it's going to have to go down because we know there's no more zeros, so this is going to curve down next to that asymptote. This stuff on the right-hand side is really high. Let's make this a 2.5. Whoops, let's make that white. 2.5, and let's try that. 2.5, I'm going to have to grab a calculator here. As long as we've got the technology, let's use it. So we need 2.5 cubed minus 2 times 2.5 squared plus 3. So that gives us 6.125 on the top. And on the bottom, we're going to have 0.5. And that gives us 12.5. So what happens is, and I'm just going to have to kind of show you what happens, because it doesn't ever come down to our graph. This thing actually comes down, and it doesn't come down to 6, but it comes down here, and then it shoots back up in that direction. So this particular screen is not going to be good enough to show us, but let's take a look at what it actually looks like on a little bit nicer graph. Notice it is stretched way up, but we do get that idea of the asymptote. The asymptote being at 2, it comes down from the top left, curves and goes down, and then you have it the little kind of U shape in the top right corner. So the processes are pretty much the same for each of those types. It's just a matter of going through the process, that 5-step process, and so do some of these as practice, and again, you'll have time tomorrow in class to work on it, and so you can go ahead and get started on that.